Here with another video. In this video we are going to study the difference between static friction and kinetic friction, as well as the factors which affect the force of friction. We have a person here trying to push this crate, wooden crate, okay, and here we can control the magnitude of the force that he is applying, okay, and here this one to control the friction, how rough the surface or how smooth the surface is. Here it's set on the middle. Here in the middle means that there is friction, and it's a medium value between none and lots. So I will start with applying a force. We will see that as this person pushes on the box does not move. So the person is applying a force of 30 Newton. This is the applied force. It doesn't move because of the friction force. It's also 30. If he increases the force to 40 or 50, okay, the force of friction also increases to 50. So as you see here, that the force of friction responds to the applied force. When the applied force increases, it increases with it. And even if we decrease the applied force, as you see here, the friction force also decreases. So let's keep on increasing the force, the applied force. Of course, the force of friction is increasing, but it will not keep on increasing forever. It will reach certain maximum value. Let's see how much is that maximum value. Here we go. It's 125. At that point, we are still at a motionless situation. If I increase the applied force more, now the box starts moving because the applied force now exceeds the maximum static friction. Now once the box starts moving, this friction, or the friction force, is still there, but it's not static anymore. It's called kinetic friction. Actually, the kinetic friction should drop a little bit under 125 because the kinetic friction is always less than the maximum kinetic friction. And the kinetic friction keeps on, approximately keeps the same value, no matter how much you push the box. Okay, that is for the difference between static friction and kinetic friction. Now we talk about the factors that affect the friction. If I'm using now the same box on more frictional surface, I increase the force of friction, you will see that this box will not move at 125 Newton force. Let me show you the value here. See here, 125. Okay, 126, and the box still not moving. Simply because the surface now is more rough. The surface is more rough, then the frictional force is higher in magnitude. Okay, let's see how much it becomes now. 185. So it increased from 125 to 185 by changing the type of surface. Okay, so with the same box, we saw by changing the type of the surface, the force of friction also changes. This is for the first factor. The second factor, if I keep the type of surface the same as in the beginning, as in the first case, but now I make it a heavier object. Okay, make it heavier object by placing two crates on the top of it. So by changing the mass, we change the weight, the force of gravity acting on these boxes, and therefore the normal force also changes, increases. Let's see now how much is the force of friction needed to move these two crates together. Remember that the friction, the coefficient of friction or the type of surface is the same as before. Uh, we needed 125 Newton force to move the boxes, or the maximum static friction was 125. Let's see how much here will be. It will be 257. Okay, so the force of friction increases when the normal force increases. Okay, so these are the two factors which affect the magnitude of the force of friction: the type of surface, in other words the coefficient of friction, and the normal force. The normal force changes when the mass of the object changes. Okay, thank you so much. I hope this video is helpful. Thank you, and bye bye.